Apples from the bins through our water flume conveyor. We're going to begin the cleaning process with heated chlorinated water, and we're ready for cleaning and waxing. We bring the apples out of the water onto a roller conveyor. The intent here is to provide even spacing for the cleaning and waxing process. Next step is our spray bar, where we apply a food grade soap to get the apples nice and clean and free of orchard residue and any other debris that we may pick up from the orchard. Run the apples underneath a shear fan to dry the apples completely, so now that they're clean and dry, they're ready for wax application. Wax applicators have sensors on them to apply just the amount of wax for a shiny, marketable apple. After applying the wax, we run the apples through a 55-foot dryer to make sure that the wax is dried for the next process.
An eccentric progressing cavity or mono pump transports the mash to the belt press. The mash level in the feeding hopper is controlled with level sensors. Adjustable lateral flappers allow the operator to optimally adjust the width of the mash cake according to mash quality. Via a variable speed feeding roller, the mash is spread uniformly on the lower belt. The height of the mash cake can also be adjusted with the feeding roller. Underneath the feeding roller, the first juice extracted through the belt is due to the static pressure of the mash. Juice extraction is continued in a gentle way in the bow zone, where the upper belt meets the mash. At the same time, pressure is slowly increased and a mash which has a good structure for pressing is formed. The L-profile roller provides a quick discharge of the pressed juice to both sides of the filter belts. A large quantity of juice is extracted at this special designed roller stage. In a second stage, the pressure on the mash cake is increased with decreasing roller diameters and more juice is continuously extracted. Additional vertical pressure on the mash cake can be applied with specially designed press rollers, called nip rollers, at the end of the pressing process. These rollers, when utilized, will help the end user try and recover the last drop of juice present in the mash. Most remaining fruit particles are separated from raw juice via a vibrating screen. Thermal treatment allows for the preservation of the raw juice in aseptic tanks until bottling. The pomace is separated from the filter belt via a scraper. Finally, the pomace is discharged via a collecting screw into a container, as shown in our example. Minimal cloudiness, hygienic construction in stainless steel, gentle extraction of fruit, minimal oxidation, high security, long lifetime, and low energy consumption are characteristic
during the year. Each reservoir can hold 110,000 liters of filtered juice. No preserving agent is added. Now we move to the next stage, which is the filling of the containers. These little drinking containers are filled at the rate of 100 a minute. The containers are then hermetically sealed. Two little sprays of hot glue are applied to the containers. This secures the straws attached onto their sides. Another automated production line fills bottles with juice. They circulate in a row on this conveyor. Bottles are washed and disinfected with hydrogen peroxide in this white sterile room. Then they're rinsed with sterile water before being carried to the filling location. Each minute, 120 bottles are filled with pasteurized apple juice and sealed with a cap in a sterile environment. Bottles are then labeled and sent to shipping. Between 20 and 40,000 tons of apples are transformed into juice yearly. Thanks to its perfect preservation, consumers can enjoy this juice at any time of the year.